Hello viewers, in this video I will be covering my internship journey at Emertxe Technologies in the domain of embedded systems. First, I want to thank Team Emertxe for giving me this wonderful opportunity. It really helped me to gain real-time experience in the domain of embedded systems. Let me introduce myself. My name is Gopinath and currently I am pursuing my final year undergraduation in the domain of electronics and communication engineering at RVR College of Engineering, Guntur, Andhra Pradesh. In this video, I will be covering the following topics. First, I will give brief overview of this internship and then objectives of the internship, then brief overview of the modules that are discussed as part of the internship, like C module, microcontroller module, and embedded system module. At the end of this video, we also see the project implementation along with the demo. So coming to the overview of this internship, the internship has started with the C module where we are taught with the various C concepts like pointers, data arrays, basic data types, etc. Then we are started with the embedded C module and then we are discussed about the hardware related topics. In the we are in the next module we are discussed about the various peripherals required to the implementation of our end project. Next, let's see the objectives of this internship. The first objective is to strengthen the knowledge of C programming and learn about the various embedded systems. Then we are also taught about the PIC MCU and its programming part. We are also taught the programming of various peripheral related to the project. And the main goal of this internship is to gain hands-on experience in programming the embedded systems. To start with the C module, in the C module we are discussed about the following topics. The topics include various data representations like signed representation, unsigned representation, and then we are taught about the basic data types like int, char, float, etc. Then we are also taught with the various operators like arithmetic operators, logical operators, and bitwise operators, and so on. Then we are discussed with the arrays, one-dimensional array and two-dimensional array. We are also taught about the pointers, functions, strings, storage classes, preprocess and macros in the C module. Next coming microcontroller module. In this microcontroller module, we thought we are trained on the microcontroller basics and the definition of the microcontroller. We are taught about the basic differences between the microcontroller and microprocessors, then the advantages and disadvantages of microcontroller over the microprocessor. It also covered the introduction to the PIC microcontroller having the microprocessor PIC 16F877A. Then next we covered the embedded systems module. In this module we are taught with the following concepts. The definition of the embedded systems and various types of embedded systems are taught as part of this module. We are also taught about the operating systems, various operating systems used in embedded systems. Here is the block diagram corresponding to a general embedded system. It depicts the various internal components that consist in a general purpose embedded system. Next coming slide shows the various requirements that we have used in the internship. The first one is MPLAB XID. It is used to code the C program required for the project. So the all programming part is carried out in the first tool, that is MPLAB XIDE. Next coming XC8 compiler. XC8 compiler is used to compile the code that is coded in the MPLAB XIDE. It is used to convert the C level high level language, that is C language, into the mission language by converting it into hex file. Then the hex file is given to the Pixim lab, which is used to simulate the virtual virtual board. In Pixim lab, we have various MCUs and processors. So in this internship project, we have used PICGenos MCU, and the mic processor used is PIC16F8877A. Coming to the design part of this project, since the project is microwave oven, the following peripherals are programmed as part of this project. The first one is matrix keypad. The inbuilt matrix keypad of the PICGenos MCU is programmed for taking the various kind of inputs corresponding to the process. Then coming next part is output peripheral, that is crystal LCD. It is used to display the various outputs on the screen. Then timer module is programmed to generate accurate time delays in the program. It is mainly used to program the timing part of the project. And then we have also implemented the various programs related to the buzzer, fan, etc. Now let's see the project demo. The project start with the displaying of four basic modes that we have programmed in the project. The four modes are: first one is micro mode, grill mode, convection mode, and then start mode. The project will be start as shown in the presentation. The start window will be started with four modes displaying as shown in the slide. Then if you look into the each mode, the first mode is micro mode. This micro mode is used to set user required time and run as per the user requirement. So the first, when we enter into the micro mode, it asks for the user to set the time. So based on the time set by the user, it will run accordingly. We can also have multi-functions while the microwave is running, like start, pause, stop. Pause is used to halt the process while the microwave is running. We can resume the process by using the start, and then we can also terminate the process in the middle of the process. Then coming to the grill mode. Grill mode is also similar to the micro mode. And then next mode is convection mode. In convection mode, the user needs to set the temperature as well as the time required to heat the food. First, the interface will ask for the desired temperature, and then it asks for the desired time as shown in the previous slide. Then next coming mode is start mode. Start mode doesn't take any time or temperature from the user. It itself fixes constant time. In this project we have taken 30 seconds, which is optimum to maintain the heat of the placed food. Now let's see the implementation part of this project. So this is the programming part of this project. We have coded entire program in the MPLAB XIDE. Here are the source files related to this project. We have individually programmed each peripheral and integrated into single project. This is the main.c file which the primary implementation of the project is carried on. The corresponding header file is placed in the header file section along with the other header files. Now let's dump this code into the Pixim lab and check for the output. So this is the Pixim lab. So this is the Pixim lab interface. In this board, let's dump the project hex file. So this is the hex file related to the main project. So I am dumping the project code into the Pixgenos board. It is powering on and the screen will be displayed as shown in the earlier slides. So by using the keypad we can navigate to the different modes of the microwave oven. Let's see by entering into the micro mode. In micro mode the user needs to set the time. So let's say 12 seconds and then we can give the minutes. So total 4 minutes 12 seconds the microwave oven will be running. So to clear the entered data we use star and to and we can re-enter. To enter into the main process we have to click the hash. Now micro oven has started its process. So here we can see the timer is running down and as soon as the timer has stopped the fan will be stopped and the user will indicate it with the buzzer. Let's see other options available here. Here 4 is used to start or resume when the process is halted. Fifth, key 5 is used to pause the process and key 6 is used to stop. Let's pause the process. So the now microwave oven has stopped its process. To resume the process we have to click 4. To terminate the process we can click 6. Now let's see the grill mode. Grill mode is similar to the micro mode. We have to set the time. I am setting time 6 seconds. Let's see the output. So after 6 seconds it will terminate by displaying like this. So next we see the convection mode. In convection mode the user has to enter the temperature. Let's say 120 degrees. Now I set the temperature. Then it requires some time to attain the temperature, so we will be displayed with the countdown time. After that the user have to give the time to maintain the heat. So that I'm for example I'm giving 10 seconds and enter. So the timer has started running in convection mode. So let's stop this process and go to the start mode. In start mode the time is fixed for 30 seconds and the microwave oven will be run for the 30 seconds. Likewise the all other three options will run in all modes. So this is the internship project we have carried out in this at the Emertxe online internship. Thank you for giving this opportunity.